solutions for question 18.4, and I'll also do question 18.5 in a minute. So question 18.4 focused on the pH of some strong acids. So these are relatively straightforward. Question A is asking you to get the pH of a 0.1 molar HCl solution. Okay, so first of all, let's just look at the dissociation of hydrochloric acid. HCl dissociates into a H plus and a Cl minus. In this case, the mole ratio is 1 mole of hydrochloric acid is to 1 mole of H plus ions. And if that is the case, then if we have 0.1 mole of the HCl, we can expect that we will have 0.1 mole of the H plus, because as we know, these strong acids fully dissociate. So if it's a 1:1 ratio, your 0.1 mole of hydrochloric acid will give you 0.1 mole of your H plus. We've worked out, therefore, the concentration of our H plus, and all we have to do now is put that into our formula for pH, which is negative log to the base 10 of the hydrogen ion concentration, which is minus log to the base 10 of 0.1, and your answer for that is 1. So that's the pH of your first solution, 0.1 molar hydrochloric acid. Let's look at the second one that we have here. The second one is a similar example. It's a 0.01 molar H2SO4. We've one slight complication in this one, which will become apparent when we look at the dissociation of sulfuric acid. So sulfuric acid, H2SO4, is a dibasic acid. So you will get 2 H pluses and you get an SO4 minus. This is like the second example I did the other night. So for every 1 mole of H2SO4, you can expect to get 2 moles of H pluses. And if we're given 0.01 moles per litre in the question, we can expect then to get 0.02 moles of our H pluses. Okay, put that into your pH formula, which is pH is negative log to the base 10 of the hydrogen ion concentration. In this case, that is minus log to the base 10 of 0.02. And when you work that out, you will get a pH of 1.7. So they're two pretty easy examples. Let's move on now to look at C. C had a slight complication in it, in that we are now looking for the pH of 12.6 grams of HNO3 in 500 centimeters cubed. So this one is like the second example that I showed you the last day. We know that we need the concentration in moles per litre. At the moment we have it in grams per 500 centimeters cubed. So if there's 12.6 grams per 500 centimeters cubed, then we're going to have 12.6 multiplied by 2, which is 25.2 grams in 1 litre. And of course, grams are no good to us. We have to change those to moles. And for HNO3, if you look up the RMM of that, you'll find that it's 63. Oops, 63. Okay. Plug that into your formula for changing from grams to moles. In other words, divided by the RMM, we have 25.2 then. 25.2 grams divided by the RMM, which is 63. So the number of moles we're actually given in this question is 0.4 moles. Right, now that we've worked out the number of moles, we can plough ahead and fill in our dissociation expression. So our dissociation equation here, HNO3, will break down to give you H plus and NO3 minus. In this case, we're looking at a 1:1 ratio between the nitric acid and the hydrogen ions. And if we are, that means that our 0.4 mole will give us 0.4 moles of the H plus. Now we put that into our pH formula, which is minus the log to the base 10 of the hydrogen ion concentration, and we have our hydrogen ion concentration. It is 0.4, and when you put that into your calculator, you will get 0.4. Well, you'll actually get 0.397, which you could round to 2 decimal places, which is 0.4. Great. Now we'll move you on to D, which is pretty much the same as that one, if I remember correctly. So in D, we're asked to get the pH of 5.48 grams of hydrochloric acid in 500 centimeter cubed solution. So again, they've given us grams per 500 centimeters cubed. We're going to have to change that first of all to grams per litre, and then we're going to have to go from grams per litre to moles per litre. So 5.48 grams is equal to 5.48 multiplied by 2, which is 10.96 grams in 1 litre, just multiplying it by 2. Then hydrochloric acid, the relative molecular mass of that is 36.5. So in order to change from grams per litre to moles per litre, I'm going to put the grams per litre over the RMM to give me the moles per litre. So I have 10.96 divided by my 36.5, and that gives me 0.3 moles per litre. Oops. 0.3, 1 sec, when I just... .3 moles per litre. Now, what do I do with that 0.3 moles per litre? I go back to my dissociation equation. So my hydrochloric acid will break down to H pluses and Cl minuses, and it's a straightforward 1:1 ratio. So if I have 0.3 moles of my hydrochloric acid, that will give me 0.3 moles of my H plus ions. Then when I put that into my pH formula, minus log to the base 10 hydrogen ion concentration, which in this case is minus log to the base 10 of 0.3, and I will get an answer of 0.5228, which is 0.52 when you round it. Okay, let us do E then, the last one, except I may have run out of space here, so I might have to, nope, we've just about enough space to do E. Okay, E. In E, we're looking for the pH of 5.8 grams of H2SO4 in 250 centimeters cubed. And you might notice straight away that H2SO4 is going to throw in a further complication in that it's a dibasic acid. But first of all, we'll start with our, oops, that doesn't look much like a G. We will start with our 5.8 grams. If that's in 250 centimeters cubed, I'm going to have to multiply that by 4 to get 23.2. Ugh, what is going on with this? 23.2 grams per litre. After that, I need to look at my H2SO4 and work out what's the RMM of it. I really should be showing you how to work out the RMM, because I've said to you on loads of occasions, if you show the working out and you make a little slip, you will still get the marks. If you don't show the working out and you make a little slip, you will be penalised. Right, so 98 grams is the RMM of your H2SO4. So then if we want our moles per litre, we're going to put our grams per litre over our RMM to get our moles per litre, which in this case is 23.2 23.2 divided by 98, which gives us 0.24. So if we have 0.24 moles per litre, we can now go and look at our dissociation equation for H2SO4. So H2SO4 breaks down into two H pluses and an SO4 minus. So for every mole of sulfuric acid that we have, we're going to get 2 moles of H pluses. And if we have, in this case, 0.24 moles of sulfuric acid, that is going to give us 0.48 moles of our H pluses. That now allows me to fill in my pH expression. So my pH equation rather. pH is minus log to the base 10 of the hydrogen ion concentration. In this case, that's minus log to the base 10 of 0.48. And that gives me an answer of 0.31875, which is 0.32 when you round it to 2 decimal places. I'll stop that one there before we look at 18.5, which were some examples based on bases.